All right, this is going to be the solution guide for the physical and chemical properties and chemical physical changes worksheet. You'll notice I have uploaded a photo of the keys completed. That way, if you wanted to just check it and didn't really have any questions, you understand what you're doing, you can do it pretty quickly. But if you want to hear a little more detailed explanation of why each of these is what I chose, then this is the place to find that information. Okay, so this first part, we're looking at physical properties and chemical properties. And so you'll notice that physical properties are things that are observed with the senses, and you can observe them without destroying the matter. Whereas chemical properties indicates how a substance reacts as it changes into new substances. And it reacts, okay, like flammability is an example of that. Okay, so the following we're looking is either chemical or physical. So blue color, that's simply a physical property. All right, that's just me observing, like a Pepsi can is blue. Okay, it's just a fact, doesn't change anything by looking at it, it's just the color of it. Density, that's also physical. You guys will recall from earlier that density is mass per unit of volume. You can find the mass of some object, you can find out how much space it occupies, it doesn't change the substance. Density is physical. Flammability or burns, that's got to be chemical because once again, you have light, heat, sound, smells. Um, you can't undo it. Once that substance burns, it's changing to something else. Solubility or dissolves. This one's kind of weird because this one could be physical, it could be chemical. I guess on the worksheet, I think I only put physical, but dissolves could be chemical as well. Like, for example, if I dissolve like salt or sugar in water, that's physical because it's just spreading the substance out. But if I dissolve like a nail in acid, that's chemical. So dissolves is kind of a weird one. You have to know what's dissolving in what. Reacts with acid, that's definitely chemical. Supports combustion. That just means it allows things to burn. So anything with burning, light, heat, smells, new substance formed, that's got to be chemical. Sour taste. Taste, once again, that could be either physical or chemical because taste, deals with shapes of molecules. That's how they kind of activate the taste buds. But then also, just by the act of tasting things, they come in contact with saliva in your mouth, and your saliva part of its job. It's got enzymes in there that start breaking things down, so it starts the digestion of food. So um, anything with taste, I'll count as either. Melting point, that's going to be physical because all it's doing is measuring when something goes from a solid to a liquid. Reacts with water, that's going to be chemical because the word reacts, that implies that it's undergoing some kind of change. Let's see, hardness. Hardness is going to be physical. Okay, that's just how easily you can bend or deflect something. Next one. The next one is luster. You may not know what luster is, but luster, that's the scientific name for shiny, how shiny an object is. So that is a physical property. You're just observing if it's shiny or not, if it reflects light. So luster, physical. Odor. Odor is going to be just physical because it's not saying a change in odor. So, for example, like you guys know what vanilla smells like. You're familiar with like lilacs, what they smell like. Okay, and it's because kind of like your tongue, your nose has these olfactory nerves, and they identify shapes of molecules. Um, and so by you smelling it, it doesn't break it down. It's just identifying shapes. So it's not a change in odor, like burning wood or something. It's just talking about, something smells. Reacts with air, that's going to be chemical because the word reacts. So it's changing in some way. So for example, uh, there are certain like metals that when they come in contact with oxygen, they rust, and some rust faster than others. Okay, the next part deals with chemical and physical changes. You'll note that a physical change is a change in size, shape, or state of matter. There's no new substances, it's just a change in form. Whereas chemical changes, it's a change in the actual chemical properties and it becomes a new substance. So the first one, you have sodium chloride there, or table salt dissolving in water. That's physical because once again, it's still salt. You can boil the water off, the salt remains behind. Number 2, silver tarnishes. That's going to be chemical. Silver tarnishes like rust. An apple is cut. That's going to be physical because you're just taking an apple and cutting it in two pieces is still an apple. Heat changing water into steam. That's physical because once again, steam is just water that's been evaporated. If you cool it down, that water recondenses. Baking soda reacts with vinegar. You may have seen this before. This is like the classic, science fair experiment where the kid makes the volcano, and they make it erupt. Well, how they do that is they use baking soda and vinegar because when you mix those two things together, it bubbles up. It releases carbon dioxide gas, and so bubbling or fizzing is a indicator of a chemical change. Iron rusting, that's definitely chemical. Okay, new substance is formed, it can't be undone. Has new properties, it's now kind of a reddish brown and flaky. Alcohol evaporating. Evaporating is a physical change. Melting ice, once again, that's physical change. Anything that deals with, melting, boiling, freezing, evaporating, condensing, any of those things, any change in state of matter, those are all physical. Milk souring for number 9, that's chemical because you can't get the unspoiled milk back out of it. Okay, there's little bacteria that eat the sugars and convert it into the stuff called butyric acid. But milk souring, definitely chemical. Let's see, sugar dissolving in water, that's physical, just like the salt. If you dissolve sugar in water, it just spreads it out throughout the solution. If you boil the water off, the sugar remains behind. Rotting wood. Rotting wood is going to be chemical because you have essentially, either like fungus or bacteria, something that gets in there and are breaking down that cellulose, decomposing those wood fibers. And so, once that wood is rotten, you can't replace it. 12, pancakes cooking. Anything dealing with cooking is going to be a chemical change, all right, because you can't get the raw ingredients out. Here's another way you can tell that it chemically changes. If I ask you, hey, you want some pancakes? You're like, yeah, I'd have some pancakes. Then I pour you a big tall glass of batter. Well, that'd bum you out because guess what? Batter doesn't taste the same as pancakes. So anything with cooking, it's going to be chemical because it changes, it breaks bonds, makes new bonds. It's different substance. 13, grass growing. That is chemical, believe it or not. Okay, you guys remember from your days as biologists when you studied photosynthesis, and you understand that plants take in carbon dioxide and water and release oxygen, forming glucose, simple sugars. Well, one of the things that those plants do, so one, they store energy in those chemical bonds in the glucose, but two, they use those glucose molecules to turn into cellulose, which is what plant cells are made out of. So they use that material to make new plant cells or new material. And so as those plants undergo mitosis and they divide and the cells split and make new cells and the cells grow, well, in order for them to grow, they need to absorb those nutrients from the environment, carbon dioxide and water, and they convert them into plant matter. So growing grass, that is chemical. Inflating a tire, it's going to be physical. You're just putting air inside of a bladder. Food being digested, that's going to be chemical. You've got acids and enzymes and things in your digestive system that break down food. Paper towel absorbing water, that's physical because what you have is a paper towel that's just soaking up the water. You see some commercials where they take the paper towels and they wring them out and you can reuse them. I never quite understood that. If you're going to wring them out and reuse them, why not just use a regular towel? That's part of the reason buying paper towels. You can throw them away. But anyway, that's that section. Okay. This next one, we're looking at chemical and physical changes. So it says an ice cube is placed in the sun. Later, there's a puddle of water, and a little later yet, the puddle is gone. Well, that is explaining physical changes. That is just melting and evaporation. Two chemicals are mixed together and a gas is produced. This is an indicator of a chemical change. So gas being given off, that is chemical for sure, fizzing or bubbling. Number 3, bicycle changes color as it rust. That's going to be chemical. Once again, the idea is the change in color and, that idea of rusting. So that metal is no longer rigid. Solid is crushed into a powder. That's physical. Okay. All that's doing is taking something in a large form and increasing its surface area, crushing it down. You'd probably be surprised to know The salt you eat, the table salt, uh, that stuff actually comes, most of the salt we consume in the United States comes from Kansas, and they mine it. It's underground. It's found in these what are called rock salt formations. So just great big layers of sodium chloride that were left from an ancient inland sea that used to cover this part of the country. And that was kind of the last part of it. So as the water receded and evaporated, all the salts were left behind, and they were deposited as these mineral deposits, these rock salts. Well, what they do is they take them, they crush them up in little pieces so you can put it in a salt shaker and sprinkle it on your French fries. So physical, still salt, just smaller. Two substances mixed together and light is produced. So this is like glow sticks. Hey, when you snap them and you break the little capsule in there and the chemicals mix and they start to glow, it's a chemical change. A piece of ice melts and reacts with sodium. So the ice melting is going to be physical, then reacts with sodium is chemical. Um, when water and sodium combine, what happens is that they'll produce hydrogen gas and heat. And if it produces enough heat, it explodes. So you can check that out if you want to go on YouTube and type in, sodium reacting with water. It's kind of a neat demonstration. Mixing salt and pepper, that's going to be physical because once again, they're still the same substances. You could sort them if you wanted. Chocolate syrup dissolved in milk, that is still physical. Okay, because dissolving the syrup in milk, like if you're allergic to milk, you can't drink chocolate milk just because there's chocolate in it. It's not a new substance, it's still milk. 9, marshmallow toasted over campfire. Believe it or not, that's chemical. I know some of you are thinking it's like, it's still a marshmallow. Yeah, but it tastes different. If it didn't, you wouldn't do it. You just eat them straight out of the bag. You'd cut out that middleman and the whole mess of having to, put that thing on a stick and hold it over the fire. So, yeah, it's cooking. Should be chemical. Then a marshmallow is cut in half. That's going to be physical. You're just taking one marshmallow, making it into smaller pieces. Okay, for this next part, we're looking at reading some different scenarios and telling us if you think these are chemical or physical. Okay, so it says your friend decides to toast a piece of bread and leaves it in the toaster too long. Bread is black, kitchen's full of smoke. It's going to be chemical, okay, because you have a change in color. It's giving off smoke. You can't undo it. 3, it says you forgot to dry the bread knife and you wash it and reddish brown spots appear on it. That's chemical. Okay, that's essentially rusting. 4, you blow dry your wet hair. It's going to be physical because you're using just heat to evaporate water. Okay, still your hair, it's still water. Number 5, in baking biscuits and other quick breads, baking powder reacts to release carbon dioxide bubbles. The carbon dioxide causes the dough to rise. That's chemical because you're producing a gas. Number 6, you take out your best silver spoons and notice they're very dull and have some black spots on them. It's going to be chemical because that's tarnished. It's a lot like rust. Number 7, a straight piece of wire is coiled to form a spring. That's physical because it's still the same metal. It's just in a different shape. Number 8, food coloring is dropped into water to give it color. That's actually physical, believe it or not, because it's the color of the food coloring. It's just dispersed throughout it, but it's still the same substance. So if you ever, use food coloring to dye something, it's common to do that. I don't know, around Halloween or something, you might dye like sugar cookies orange so that they can decorate them like pumpkins or something. It doesn't change the fact that they're sugar cookies. It's just the color of the dye gets dispersed throughout. So I would say that is physical. Chewing food to break it down into smaller pieces, that's going to be a physical change. So just tearing, so you bite into a chicken leg, use your teeth to bite it. Still chicken, just a smaller piece so you don't choke. Changing the starch into sugars by enzymes in your digestive system, that's chemical because you're breaking down large molecules, macromolecules, into smaller things we can absorb. Number 10, in a fireworks show, the fireworks explode, giving off heat and light. That's going to be chemical. Light, heat, smell, all that stuff. Love the 4th of July. Okay, last part, true or false? Changing the size and shape of a piece of wood would be chemical. False. That's physical. It's still wood. 2, it says in a physical change, the makeup of matter is changed. That's false. In a physical change, the makeup is not changed, just the size, shape, state of matter, its physical form. Chemical changes the matter. Number 3, evaporation occurs when the liquid changes into a gas. That's true. 4, evaporation is a physical change. That is also true. Number 5, burning wood is a physical change. False. Light, heat, smell, sound, the wood's gone, changed into other things. Number 6, combining hydrogen and oxygen to make water is a physical change. False. That's chemical, because when you combine hydrogen and oxygen, first off, it does it in a very spectacular way. Okay, it explodes. Light, heat, sound, all that stuff. And plus, you're making new substances. So, yep, that's going to be chemical for certain. Number 7, breaking up concrete is physical change. True. Number 8, sand being washed out to sea is a chemical change. False. That's just physical. That's just, erosion, just the water breaking the rocks up and moving them around. 9, when ice cream melts, a chemical change has occurred. False. It's physical, still ice cream. I mean, you can technically put it back in the freezer, it'll refreeze. It never quite tastes the same because, your refrigerator doesn't freeze it the same way, and the crystals become large, and it's not smooth like it is if you get it, from a place that sells it. Let's see, and then finally 10, it said acid rain damaging marble statues is physical. Nope, that's chemical. Okay, you can see that if you look at statues, that were made of marble that were around, 100 years ago, and you look at them today, a lot of them they lose their definition because the acid rain will dissolve some of that marble that's in there. Okay, so that's that, and we'll do a little bit more review, and then we'll have some material. We'll take a short quiz.